Hi. In the implementation of the 5-level cascaded edge bridge using the level-shifted PWM, we have seen that for all three phases, we used three separate blocks to generate the pulse width modulated signals, which you can see in this Simulink file here. So you see for phase A, we had created the PWM signals using one MATLAB function, and same also for phase B and C. If you have a very large simulation, we can avoid this type of redundancy. As I mentioned before, I took it separately because I wanted to have my file structure organized so that I can follow it in an easier way. Now, say for example, I want to get rid of the redundant 2 blocks and want to integrate the implementation of the 12 pulse width modulated signals into one. To do that, let's get rid of these two. I will keep the go-to file since we'll need it from this block as well. Let's double click here. So here again, the M file is exactly the same as the previous video. And the only change we're going to make here is the function of the PWM. This was the generation of the triangular waves. Here we can see it here. At this point now, we have only one reference wave. The target is to bring the other two phase reference voltages here. So instead of 3, we have all the 3 reference voltage in the one scope instead of 3 different scopes. To do that, first thing is to write the sinusoidal reference wave as a vector, which we can write as 0, which is phase A and with no phase delay, so 0, then minus 2 pi by 3, which is phase B, and minus 4 pi by 3 is phase C. So in the single block of sine wave, we have 3 different signals of sines as a vector of sine waves. This is now input to our PWM generation function. Triangular wave is same. There is a 4 carrier waves with 2 kilohertz frequency. And the target is to generate for example, bridge H1, all the PWM signals for 3 phases. So here should be, instead of 4 signals, there should be 12, and same for bridge H2. To do that, since now we have a vector in sine wave, and I would like to call that phases of sine as phase, a pH for phase. But before that, let's initialize a new vector for the signals. Let's say the PWM H1 matrix. And since we're generating for each H bridge 4 signals and there are 3 phases, so we have a 4 by 3 matrix. This is for H bridge 1, and we can just copy and paste for the second bridge, which with the same dimension. Now we can save a for loop for 3 sine waves. So for, let's say, pH is equal to 1 to 3. pH stands for the phases, since we have 3 of them, so it runs from 1 to 3. For the phases, we will continue generating as we had before. So it's phase 1 to 3, and this actually should come. Is there a way to indent all of them? So this comes for the for loop here. So let's do this all. So I just added the index or indents offline so that I don't take your valuable time. So you see we have the initialization. I also added the relevant comments for better understanding. This code is exactly the same as we had previously, and you see we have the comparison of the carrier waves with the reference waves, but the only difference is that now we have, instead of only sign, we have the vector of sign. So if for phase A it should be sine of 1, then sine 2, and sine 3. This continues 3 times, and the calculation is done as exactly before. And here we can finally give the output to the Simulink environment and then finally to the PLECS environment. So what I would like to add here is assemble the column for this phase. That means let's take another variable, PWM H1 matrix. And then for phase, all the phases, let's the pH is equal to, and we had this it's for H1, so we need to take all the signals for H1, which is H1 S1. It's a column vector, so we take semicolons, then H1 S2, H1 S3, semicolon, H1 S4. And similarly, we can do it for the bridge number 2. Just change the name to H2 and it's done. Now remember, at the output of this function, we have 12 signals here. So we need to reshape our output signals here, which is done with these 2 commands here. So these 2 lines of code and these 2 lines of code are extra, which was absent in the previous videos since we had it done in 3 different blocks. So in PWM H1, we had to reshape it so that we have a 12x1 vectors, which is done exactly here. So if we specify that we want to have a column vector, so we only specify the column 1, and if you just leave a blank set of square brackets, then MATLAB determines it automatically, or you can specify here 12 as well, it doesn't matter. So since we're done with that, and since we only have this 1 block for 12 pulse generation, we need to adjust also the signals here. Remember, for H1 we have 12 pulses. That means we will have 4x3 matrices. That means all the 3 phases will get their signals for bridge 1 from this channel. So we need to take a demultiplexer, and the output port is then 3. So this should go as, so this is phase A H1, then phase B H1, then phase C H1. This is the sequence. So I'll call it PWM, then A for phase A H1. Then we have PWM A. Now it should be B H1. And the third one in this series is the PWM for phase C and bridge H1. Similarly, we need to take for the bridge 2 as well. So I'll take here PWM A H2, then we have B and C, let's call it PWM BH2, and finally we have PWM CH2. Now this is ready. Let's extend it for better visual. Where is it? Here. Good. Now we have for, let's see if they are okay. It is not here. PWM H2A. Yeah, these are correct. So we have for PWM A, for a phase A, we have H1 and H2, which are the case here as well. Now we can take for phase B, which is already here, and for C is here. Similarly, for bridge 2, we have phase B here and phase C here. So you see, from the 3 different blocks, we have now a single block for all 3 of them. But of course it requires some advanced signal routing. Sometimes it could lead to some confusion where the signals are coming from and exactly where they're going to. So it requires much more attention to details. And this power circuit block is exactly the same as it was before, and the go-to blocks as well. So if we run this simulation at this point, there should be no errors, I suppose. And for the sake of peace of mind, let's check now. So you see we have 4 carrier waves, and instead of 1 reference wave, we have 3 reference waves, which is specified. And now the pulse width modulation signal generation is now taking place at the same time in this window. So for phase A, the comparison is taking place and the calculation is being carried out in the function block for A, B, and C respectively. And the output signal values are being given through these terminals here. Let's check the leg voltages. So this is only, maybe I should, okay, this generation. Let's check it. It seems to be the same for all of them. So maybe I skipped a part somewhere. Let me check. So let's concentrate here. This is what I just mentioned a moment ago. This requires quite attention for signal routing. I myself was mentioning that it's confusing. So let's see what's going on here. This for A, H1, B, H1, C, H1, A, H2, B, H2, C, H2. So these are okay for phase A, H1, H2. For phase B, so this is now not okay. So this is the confusion here. It should be CH, but it is there. BH2, CH2. So it took me a little time to figure it out. So I somehow mismatched the connection somewhere, and then I fixed it. Now it should be working. So you see, I have also organized the signals according to the bridge number. So we have phase ABC for H1 and ABC for H2. And as I said, these connections are the same, and the script file is also the same. If we now run the simulation, let's do it again. It's running and complete. So inside the simulation block, the measurement shows now the correct results. So this was the voltage output from H-bridge 1. The second window is for H-bridge 2, and the second and the third one is the summation of the above two windows, which is now having 5 levels. 1, 2, 3, 4, 5. Yes. So this way, if you pay a little more attention, you can reduce the number of blocks if you wish to. And of course, keep in mind that it also requires considerable amount of concentration. Otherwise, you will have a lot of errors in the simulations. Thank you for watching.